Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, I am going to cover something about the inspection and maintenance of the points and crossings in Indian Railways. Okay. So earlier I have uploaded some videos on points and crossing, the parts and components, and also for the layout designs, how the layout has to be laid on the ground. Okay. And for that how the required parameters have to be calculated and using them how they are fixed on the ground. So we have seen. So this is something about the maintenance, inspection and maintenance. You will see. So already we have discussed in the earlier videos about the points and crossing, the different parts of the points and crossing. So we have three parts, namely switch portion and crossing portion. In between we have the lead portions. Okay. So as far as the points and crossings is concerned, normally we don't provide 120 cant in the points and crossing because of the crossing. Crossing portion, it is serving for both the main line as well as turnout line. So for the purpose of this one allowing the traffic on both sides and turnout side smoothly. But whereas approach track will have the only 20 cant. So, however, they are to be used out. When you are connecting at the SRJ, that is facing point, and also at the heel of crossing. So, the both locations we are supposed to ease out the only 20 cant. That means approach of SRJ and the behind the heel of crossing 4 sleepers, we are doing the easing out of only 20 cant. Okay, that's to be ensured, to avoid the jolting, jerking. That is why this is to be ensured. Okay. Next, in the SRJ and heel of crossing, we should not have the combination of push plates. That means the points and crossing is 60 kg, right? Approach track is 50 kg. So we cannot straight away connect at the SRJ and the heel of crossing. So minimum one rail length at least we must have the same rail section of the points and crossing. Okay. Then after that you can provide a combination push plates. Okay, in case of difference in rail section. Okay, and also another this thing, in order to ensure smooth riding over the points and crossing and also safety and maintenance point of view, we are supposed to weld all the joints in points and crossing. That means SRJs and all lead joints we are supposed to weld. Of course, the crossing portion, since CMS crossing, we can't weld it normally. For that, we are providing the jammed joints. That means normally we are providing gapless joints. Okay, we are providing gapless joints, otherwise called as frozen joints. Okay, but however, in future we will have that weldable crossing. If that is the case, even the crossing also we can weld, so that we will be able to smooth riding over the point. Okay, and also another this thing, the provision, general provision instruction they given in IRPWM paragraph 429(1) is regarding spherical washers. So wherever we have tapered portion, that's there we must provide a spherical washer. That means cup and moon washer, we should say. That washers we have to provide at the tapered portion. That means normally in the crossing portion we have the taperedness on both sides. So there we will provide under both sides the spherical washers. But as far as the heel of switch is concerned, one side it is stock rail, that's right, and turnout side normally taperedness will be there. So in this case, one side normally we used to provide the spherical washers. But here for uniformity sake, the instructions are whatever may be the hand, that means whether it is right hand turnout or left hand turnout, we are supposed to provide the spherical washer only left hand side. Okay, the left side of the heel of switch. Okay, irrespective of the hand. Okay, so that you must ensure. The purpose of providing spherical washer, all you will know, because when you are not providing the spherical washer, what will happen? So because of the taperedness, only there will be edge contact. The uniform contact will not take place. Only the edge contact will be there. Because of there will be stress concentration. When you are tightening the bolt, the entire force will be only in the edge. Okay, so in order to have the perfect fit, flush fit, and also for the force should be uniformly gets distributed, and we are providing the spherical faucets so that we are providing the spherical washes. There will be uniform distribution of the load. Okay, we can avoid the stress concentration at one edge. Okay, this is the reason why we are providing the spherical washes. Okay, this is something about it. The general provision instructions given in the IRB para 429.1 we are supposed to ensure. Okay. Coming to the inspection, suppose first let us see the switch portion. Switch portion, so important is what our tongue rail and stalk rail, and the connecting components like stretcher bars. So they have to be critically examined. Then particularly if you are checking our tongue rail, we have to check it for the damages, whether it is in good condition or not, how to decide. So the Indian Railway Protective Manual para 429 one says, chipped or cracked over a length of 10 mm aggregating to 200 mm within 1000 mm from toe. If that is the case, it is in not in good conditions. So it requires renewal. It says that what does it mean actually? First actual top switch, it is 1000 mm, that will be 1 meter. Suppose there are some damages chipped off, the width is 10 mm, the depth also 10 mm. So like that, in so many places when such damages are there, so aggregating to total is coming to 200 mm or more. If that is the case, it is in bad condition. That means it is chipped off or cracked. So in this case, we have to plan for renewal of the tongue rail. Okay, that is something about the tongue rail condition. And coming to the another this thing, whether it is badly twisted or not. So when it is badly twisted means if there is a gap in the between the stalk rail and tongue rail, the gap is more than 5 mm. It's not properly housed. Instead of this thing butting, it's giving a gap of 5 mm. That means it is badly twisted. That is too dangerous, because sometime we will have the thin flange. The gap is 5 mm. It will go into that result to derailment. So that is why that also we have to check it up, and the gap should not be there more than 5 mm. Okay. So there is another conditions take one, and also normally the stalk rail, there will be more wear and tear. Sometimes there will be burr in the stalk rail, and that will preventing the proper housing of a tongue rail. That is exceeding the prescribed value, then that is the case, and we have to plan for renewal of the stalk rail also. So then in case of non-housing problem is there in the points and crossing is interlocked. If that is the case, that is to be attended to only jointly with the SLT stock. Okay. Also another this thing, we are having the anti-racing stretcher bar, the first leading stretcher bar. Then normally that will be extended even beyond the tongue rail to go under the flange, so that it will prevent the tongue rail gets lifted up. So for that extension is provided, but there must be a gap below the flange of the stalk rail. That range has been prescribed, that is 1.5 mm to 5 mm should be there. Okay, that range you must ensure. So these are the thing exclusively provided when you are doing the inspection at the switch portion. Okay. In case of it is not satisfied this condition, and we have to plan for a renewal of the specific components. Okay. This is something about tongue rail inspection, and in general normally interlocked points should be attended to along with the SND stop. In case of non-interlocked points, then PV persons can do it. Okay, that's what it says. Then another this for you have to do the greasing of the face of the tongue rail to reduce the wear, because always the tongue rail will subject to more wear and tear. Okay, there will be, when you are particularly in the turnout side, when it is negotiating, because of the outer will having the continuous contact with the tongue rail, there will be more wear and tear in the turnout side tongue rail. So to reduce the wear, normally it is better to lubricate it, okay, periodically. So that what's the instruction that has been given. So in addition to that, on the switch portion, and you must ensure that The tug rails are properly seated on the slide chairs, and the bars against the slide blocks. All those things you have to ensure. And also normally the switch portion, I mean particularly in the toe, actual toe, normally we used to ensure some slack gauge, plus 6 mm. That slack gauge you must ensure. And for providing, for ensuring that necessary steel packing also you can provide. So, and of course stretcher bars, you must ensure there should not be any this underneath your leading stretcher bar should have the proper clearance and properly disconnected. And whatever stretcher bar we are providing, in case of interlocker points, normally it should be insulated, and all insulations and all, like any renewal is to be undertaken, it should be done only jointly with the S&D department. Okay, these are all things you are supposed to ensure. And of course, coming to the lead portion, so lead portion, from switch portion to crossing portion, that portion is lead portion. So there, the lead curvature, that means turnout curvature, you must ensure properly. For that, we are supposed to ensure the the alignment, whether it is proper or not. And for that, see IRPWM para 429.4 stipulates how the the curvature has to be checked and all. And for that, we have to measure the verse signs. That means from actual toe of switch to the toe of crossing. So we have to mark stations. Normally 3 meters interval we have to mark stations, and we have to measure verse signs on 6 meter overlapping cord. Okay. So that you must do. And whenever you are checking the verse sign variation should not be more than 3 mm over the theoretical the verse signs required for that turnout. For example, if it is 1 in 12 turnout, normally some 10 mm verse signs will be there. Okay, normally our verse signs you can just work it out using the relation V equal to C squared by R, or V is equal to 125 C squared by R, so that we will be getting V in mm. So there, for a 6 meter cord, if we are working out for the radius of 440 something, so we will be getting verse sign equal to 10 mm. So close to 10 mm. Okay. So when we are measuring the verse sign, should be plus or minus 3 over the 10 mm. So 7 to 13 mm we can provide. If it is more than, exceeding the limit, not within the limit, you are supposed to correct the turnout alignment. Okay, that you must see. And they given specifically how these sections should be marked. That means you have to start the curvature. Curvature will start from actual toe switch. So the 0 station will be at ATS, and subsequently every 3 meters you have to mark. You have to end at heel of, the toe of crossing. Okay. So marking station at 3 meter interval and recording verse sign at 6 meter overlapping cord. Okay. This is something about the lead portion, turnout curve, how it's to measure, and also even the turnout curve also we have to measure like that. Okay. So there also, same every 3 meter interval, and you have to mark stations and you have to measure the verse signs. So whatever radius you have fixed, and for that you have to work it out the verse sign. The variation you should ensure should not be more than 3 mm over the theoretical range of verse signs required for the curvature. Okay, that you must ensure. And coming to the sleeper spacing, normally you must ensure. Sometime there may be some gauge variation will be there, or some even the curve alignment also. So because of the improper spacing, suppose if it is if it is found it is variation is more, and you have to check up the spacing of the sleepers. For each and every turnout, the spacing have been given in the plan. The drawings available, and after the drawing, the spacing was supposed to ensure. So already discussed, in case of fan shaped layout, how the orientation of sleepers are ensured. Okay, so that means from SRJ to heel of switch, normally it will be perpendicular to the stock rail of main line, and after that from heel of switch to the toe of crossing, you have to mark the spacing in the the main line on both sides, main line. Okay, track you have to measure mark the spacing. The same spacing will be different. So outer side spacing will be there, inner side gradually it will be reduced. Okay, in order to get the orientation. Okay, slightly give some inclination. Okay, these are supposed to ensure that. And beyond the toe of crossing, you are supposed to provide the spacing for the bisector drawn the crossing end. Okay, with reference to that line you have to mark the spacing and you have to orient the sleepers. So this is the way actually we are laying for points on crossing the sleeper orientation. At the same time, even if you have any problem during maintenance, also some gauge variation and alignment problem is there, then you can check it up comparing with the drawing. Okay, the spacing what are available, you can just compare with it whether it is existing spacings are correct or not. Okay, you can check it out. And coming to the crossing maintenance. So as per IRPWM para 429.3, so you have to, while you are checking the crossing portion, you must see the condition of the crossing, particularly the nose of crossing of visit. That means because this nose of crossing is, it's a very the critical location, so there will be more impact because the movement will be in the main lane as well as turnout line. So both side traffic this crossing will face, and also due to the impact this location is susceptible for the damage. So based on the extent of damage, you have to decide whether it is to be entire this one crossing has to be replaced, or so you have to plan for the recondition of the crossing. Okay, so that thing you have to do. And moreover, because of this impact at the nose of crossing, even the sleepers below, the packing under the sleepers also will be loosened always, and frequent packing has to be done. And also because the vibrates, it will be more wear and tear to the components, the clips and liners and even rubber pad crushing, all those things will take place, liner crushing, all those things will take place. So this location has to be properly watched and attended to, okay, to the deficiency. Okay, and regarding the clearance, so normally we have check rail on both sides opposite to the nose of crossing to ensure that the wheel is going in the right path. And for that, check rails are provided, and the check rail clearance you must ensure that is should be 41 to 40 mm in the case of a fan shaped turnout. This is as per the schedule dimension. Okay, like that wing rail clearance also the nose of crossing used to ensure the same clearance 41 to 45. But of course, it is being a CMS crossing, it is fixed. If at all, if there is any variation, it will be because of the bearing out. So like some throat distance, the nose of crossing this here, throat distance also it is a CMS crossing, it's fixed, there won't be much variation here. And in the case of obtuse crossing, square to each other with respect to center line of acute crossing in case of diamond. So in the case of diamond, the obtuse crossing square to each other with respect to center line of the acute crossing. These you must ensure. Okay, so these are the crossing portion you must ensure, and apart from the measurement of the wear. So that I will discuss in the next slide. Okay, so in the case of diamond crossing, the previous slide it was mentioning, so this obtuse cross should be square, exactly square to square with reference to the center line of this one acute crossing. Okay, this one must ensure here. Okay, this is something about it. And regarding the wing rail nose wear, so the limit has been prescribed in the Indian Permit Manual. So maximum wear 10 mm can permit. Okay, but 8 mm in the case of weldable CMS crossing. But whenever they reaches the limit of the following values, you have to plan for the renewal. That means in case of built-up crossing, when it reaches 6 mm, you have to plan for renewal or reconditioning. In case of CMS crossing, then 8 mm. Okay, it reaches 8 mm, you have to plan for reconditioning or renewal. And in case of weldable CMS crossing, it is 6 mm. So these limits have been prescribed. We are supposed to follow that. Okay, this thing. And also while we are measuring the wear the nose are crossing, some deduction also we must make to get the actual wear at the nose are crossing, because so there is a slope is given in the the CMS crossing, particularly CMS crossing. Because of the slope given, so 120 slope is given. So for that, we have to make deduction to get the actual wear. In case of built-up crossing, it is not so, because it is level is same. Okay, there is no 120 slope is given. It is same level. Both the wing rail and the crossing will be same. That is why 0 mm deduction. We have to simply as it is whatever measurement it is actual. But in the case of CMS crossing, in case of 50 gauge, 2 mm you have to detect. That means total depth we are measuring, the wear, for the wear measurement we are measuring, and from there, from that we have to detect 2 mm. That will be the actual wear. In the case of CMS cross 50 gauges, 60 gauge it is 2.5 mm deduction we have to make for 120 slope. It is only for wing rail. But in the case of nose of crossing, that is actual nose of crossing. So as this, because the nose of crossing slightly it's lowered, it's not in a same level. So because the coming wheel, the coming wheel should not hit with the tip of the crossing. That is why it's slightly lowered, slope. That is why the 6 mm level difference will be there. That is why we have to detect 6 mm. Okay, the 6 mm actually exactly it is there. There is no wear. So it is more than 6 mm. There is a wear in the case of built-up crossing. And similar in the case of CMS crossing, is 6 plus 2, 2 slope and 6 mm the lowerness. So more than 8 mm, that means it will be a wear. So that amount will be actual wear and the actual nose of crossing. The CMS 50 gauge. In case 60 gauge, it is 8.5 mm deduction we have to make. And similarly, so we are supposed to measure, the wear, the 9 mm behind the actual nose of crossing. There for the built-up crossing 0 because the level is maintained. And heated crossing it is 3.5 mm. CMS crossing only because slope 2 mm reduction, and 60 gauge section it's 2.5 mm reduction we have to make due to 120 slope. And WCM, CMS crossing 160 gauge 6 mm, and WCM 160 gauge 5.7 mm. These are all reduction we have to make for getting the actual wear. So this is about the guidance given for the measurement of the actual wear in the case of wing rail and nose of crossing of the crossing. Okay, this is something you are supposed to follow that. And coming to the inspection schedule of the points of crossing, so the schedule, the periodicity has been prescribed for the officers, that is ADN and SSC JS. Okay, as per the Indian Permit Manual, this we are supposed to follow that. Okay. As far as ADNs are concerned, for all points on crossing the running lines, so once in a year, so he must check, okay, and record in the register, okay, prescribed. And 10% of the points on crossing on other lines, that means non-running lines, 10% he has to check, inspect. And the other thing, there are two pro forma is there. One is annexure annexure 4/3. And annexure 4/3A. The two annexures are there. The annexure 4/3 is a detailed inspection. Annexure 4/3A is a slightly it is a less inspection will be there. Okay. Okay. So all points on crossing on main line shall be inspected as per the pro forma at annexure 4/3. Detailed inspection will be done. In case of non-running other points on crossing, non-running or other points on crossing, you can inspect the and record the details of inspection in the annexure 4/3A. Okay, this is for ADN's inspection schedule. And as far as SSC JPV's inspection schedules are concerned, for passenger and running lines, once in 3 months on rotation basis by SSC in charge and JE SSC PV sectional. Okay, so once in 3 months. And other lines, yard lines, non-running lines, once in 6 months on rotation basis, okay, by SSC and J is concerned. Okay, and the SSC PV in charge and sectional, JPV or SSC PV, they have to do the inspection, okay, on pro forma annexure 4/3 every year. So once a year you must do the inspection as well as this one, the pro forma 4/3. Okay, every year. Subsequent inspection they can do in the annexure 4/3. Okay, this is as far as the inspection is concerned for the ADNs and SSCs, and they have to follow that. Okay, and coming to the recondition of the points on crossing, they can, so manual way of reconditioning also be done for switches as well as the crossings, and robotic welding technique also is being adopted. Okay, so normally this in case of crossings normally institute reconditioning is done. In case of switches normally outside of track it is done. Okay, the level sys or in the depot is being done. Okay, this is the general guidelines for the recondition of the switches and the crossings. And in case of robotic considering, it is a computer controlled torque welder. It is a computer controlled, and the wire is used, that is coated wire, and it is flux coated, so that while during the welding so it won't be any liberation of gas. Okay, to eliminate the operator exposed to the weld fumes. Okay, so that is being ensured here. And because of robotic reconditioning, all records of welding parameters and events are stored in the memory. Okay, for later reference. So it is computerized. Okay, and it will be more effective. Okay, this can be done, and really fixing some agency. This is reconditioning can be done. Okay, for the crossing and the switch portion. And even the manual means also that it can be done, the reconditioning of the crossing. Okay, that also possible. And when we are selecting for reconditioning, the condition should be, watch condition of crossing should be all right. Okay, and that will be selected by the SSE PV and JEPV concern. And the wear limit must not exceed the specified wear limits, and no crack. Suppose crack is there, if more crack, and we cannot go for reconditioning, you have to replace. Okay, once for all. But in case of crack, it is only exceeding 3 mm is there, and it's not acceptable. So up to 3 mm. So if it is there, okay, you can go for reconditioning. If it is exceeding 3 mm, you have to discard. You have to go for only renewal of crossing once for all. Okay. This is something about the selection. Okay, of crossing for reconditioning. Okay. Then so normally before selection of crossing and ultrasonic testing how to do. Okay, that also, if it is no internal flaw, then we can go for it. If it is internal flaw, we have to replace it. Okay, this also you have to keep in mind. And of course, as you said, the tongue rail reconditioning, so normally you can do it at sys, level sys or depot, or of course crossing we are doing in institute itself. Okay, and while we are doing the reconditioning of your tongue rail and shock rail also, you can recondition. Okay, you can whenever it is there, you should recondition to ensure the proper butting. Okay, can be done. And normally the completely this welding should be done only the certified welders. Okay, the chemist and metallurgist railway checks the competency, and CTE of the concerned railway nominates the departmental welders. Okay, non-departmental welders RDSO approves. Okay, welders certified by the RDSO. Okay, so only they are only supposed to carry out the welding operation. Only certified welders only. Okay. And in the case of welding electrodes, normally you must use H3B, H3C. Okay, based on it is giving a service life of 35 GMT H3B and H3C 50 GMT is there. So only these type of electrodes only we are supposed to use, and normally these electrodes are being procured from the source, approved by the RDSO. Only from RDSO approved vendors only we are buying these electrodes H3B and H3C. These are something about the electrodes. Okay, which are to be used for resurfacing of a crossing and these tongue rails. Okay, so whenever the electrodes it should be properly stored. Okay, should be in this dry storage, and normally 4 mm diameter electrodes we are using it. And so if it is any the discard, the cracked or damaged electrodes, that means that there is we must ensure. And the coating, if it is it's not there, or if it is cracked, we should not use it. We should discard. And normally the dry electrodes, you have to dry electrodes at 130 to 170 degrees centigrade for 1 hour before use. Okay. These are some instructions available in the manual, and you are supposed to follow that, okay, while you are doing the reconditioning of the crossing, okay, whether manual means or robotic means, okay. So this is a pro forma for inspection, detailed inspection of points and crossing, that is annexer 4/3, okay. Whatever I discussed earlier, all those things will be in this pro forma, and we are supposed to inspect all the parameters and condition of fittings, and so they have to be recorded, okay, by the inspecting officials. This is 4/3 means that is detailed inspections. Here we have around some 22 items are there. That is recording complete, some the details of points and crossing. Then regarding the inspection details, will start from here. There completely condition of drainage and switch portion, gauge, cross level, and regarding the condition of tongue rail, everything, and structure bar clearance, and throw off switch, okay, and housing condition and heel divergence, all those things, you are supposed to record. And even lead portions, normally, this turn out worse sign, as well as every 3 meters interval, 6 meter record, and gauge cross level of the lead curvature, and also the the crossing position, and gauge and cross level, and as well as the clearances, check rail clearances, finger clearances, and also the wear ahead and actual nose crossing, and behind the actual nose crossing. All those things, you are supposed to record. And okay, and next, this is the continuation. I think it's including even turning curve also, we are supposed to inspect, as well as the annexure 4/3 is concerned. Here around 22 items are there, okay, they have to be done. And coming to annexure 4/3A, it is slightly, it is reduced number of items. It is coming around some 16 items, almost whatever it's covered in 4/3 is covered, but turn in curve, it's here is missing. And also all this switch portion and crossing portions, all those things you are supposed to record. So after recording it, so you have to see the existing parameters and its condition of the fittings, and any found deficiency we found, and you have to plan for rectifications, okay. So this is something about the inspection, the details. And also whatever we have inspected, that's to be recorded in the online, that means in the track management system, okay. So this is something about the inspection and maintenance of points and crossing. And already discussed, regarding SOTs, as far as checker clearance is concerned, 41 to 41 mm to 41 mm we are supposed to maintain, as far as, since it is a fan shaped PSC sleepers, finger clearance and checker clearance, you are supposed to ensure this one. And of course, I discussed regarding throw off switch, that is toe opening, existing work 95 mm, and new works 115 plus 3 mm, and for thick works is 160 mm is there. So these are some SODs already discussed, okay. So with that, we will conclude this video, okay. So this is something about the inspection and maintenance of the points and crossings, okay. So you can now visit my website also. There also I will just upload this video, and also other application also available for civil engineers as well as permanent engineers, and make use of those applications. And also is my number, contact number, and it is my email ID. So you can send your feedback and comments, okay. If any improvement require on this, my application, you can communicate to this email address, okay. So thank you for watching, and we'll meet you in the next video.